Right, so number 2, we're going to define a logarithm. Just from the first part of this logarithm, we've talked about what logarithm consists of. We have the logarithm in terms of the name. So we have logarithm. We always have the base, the level, and the power. So that's how we write logarithm. And the base is always a number. Level can be a number or variable, and the power can also be a number or variable. So one good example would be log to base e 3 squared, where e is a number which is 2.718281, and it goes on. And 3 obviously is a number, and its power is a number which is 2 in this case. And just don't forget that we also could have log to base e x squared, where the base is a number. Base is a number, and which is e, and the level is a variable, and the power is a number, which equals 2 in this case. So with the definition of a logarithm is used to solve an exponential function. Also, a logarithm can be used to reduce a curve into linear or straight line equation, like a straight line graph. So linear is straight line. So that's what you can use a logarithm for. Logarithm can be used to solve an exponential functions. And a logarithm can also be used to reduce a curve. That means you can turn a curve. If you have a curve like that, you can turn that curve into what we call a straight line graph. So using log. So that's what you can use log for, really. In terms of the definition of a log regarding the exponential function, so now let's do an example in this case where we have 16 can be considered to be 2 to the power of 4. And so we can take logarithm on both sides. So I'm going to take log, and the base of the logarithm I'm taking has to be the base of the exponential here. So that's the base 2 here I'm going to use. So that's the base. So I'm going to take log of that base. So I will say log base 2 of 16. So I'm multiplying both sides by log of base 2. Should be equal to log of base 2, 2 to power 4. And one of the rules that we will come to learn in logarithm is that the log of a, level a, always equals 1. So log of 2, level 2, log of base 2, level 2 will always be equal to 1. Another rule that we're going to learn is that which is called power law in logarithm, is that if you have log of a level b to power c, that can be written as c log of base a level b. So the c has moved to the front of the log. And that's what we called power law, because the power has been moved to the front of the log. And that's what we get here. So a good example is here in this exercise here, what we just solved. So we now have 4 log 2 of 2, log base 2 of level 2. And we know what log base 2 of level 2 is 1. And that will give us 4 times 1, which equals 4. So what we're trying to say is log base 2 of 16 is equal to 4. So we've transformed logarithm from we've transformed logarithm into indices. So that's an indices here. That expression here is an indices because of the power of 4 there. So we can actually show how we get that. So we can get back to the indices again by using this rule. The base is raised to the equal there. So we raise that, and that will become equals to the level. So that meant we get 2 raised to power of 4 will be equals 16. So we'll get back to where we started from again. So that's the relationship between logarithm and exponential function. In this definition, we can see a relationship between exponential functions. So I have, let's do logarithm here, and exponential function. And a line drawn between them. And so this is what we call the inverse relationship. When we have log of a level b, if that equals x, that can be written in this case, raise a to power of x, and the answer will be equal to the level. So we get a to the power of x equals b. So that's the relationship between log and exponential function, the inverse relationship between them. And we can try some more examples. If y, let me just rewrite this. If we have x equals log a y, the exponential relationship will be, you can see, raise a to the power of x, raise a to the power of x, and the answer will be equal to y. So that's raise, and that will be equal to y. So therefore, we're going to get a to the power of x equals y. So that's the relationship there. Let me write it out again, because it's quite, so if I write log a y equals x, all I need to do now is raise a to the power of x, and the answer will be equal to the level. It will be equal to level. So I'm going to get a to the power of x equals y. So this is an exponential function here, and that is a logarithm function there. And that's the relationship between them. And that's why we say we use log to solve exponential function and exponential function to solve log. If I want to get back to the log, if I have y equals a to the power of x, all I need to do is multiply both sides by log of base a, the base here. So all I need to do is multiply both sides by the log of base a. So I'll say log of base a of y, level y, equals log of base a, level a to the power of x. So all I did was multiply both sides. So times both sides by log of base a. And that's what I get. Now, from the power law, the x will come to the front. So I'm going to get log of a x. That's using the power law. So that's power law. And now we know that, we also know that log of log of base a of level a is always equal to 1. So therefore, I get log a y equals x times 1, and that becomes x. So I have converted my exponential function y equals a to the power of x to log a level y equals x. So this is, here is the exponential, and here is the logarithm. So that's the relationship between exponential and logarithm, and that's the definition in that sense. A logarithm is used, if you go back to the top of this expression, a logarithm is used to solve an exponential function, and a logarithm can also be used to reduce a curve into a linear graph. We'll do that at some point later, not now. So that's the definition there of a log. So let's do some simple example. If you're given log of base 3 of 9, then all we need to do, and we're told to solve or evaluate. So let's evaluate that. That's an example. So what we need to do is equate it to x. Yes? We equate it to x. And now we need to raise that. So now we'll write it again just to make it look neat. We raise that to the power of x. So that's raise. And the answer will be equal to the level. So we're going to get 3 to the power of x equals 9. So that's good. But we also know the clue is also here. The power, the base is 3. So we can write 9 as 3 times 3. So that meant 3 to the power of x equals 3 squared, because that's 3 to the power of 1 plus 3 times 3 to the power of 1. We add the power if the base is the same. And therefore we can find x equals 2. So the answer is that the log of base 3 of level 9 equals 2. So that's what they're asking us to evaluate, to show or to express the value of log of level base 3 to level 9, and that equals 2. We try another one just to see. So let's try another one. If we told to evaluate log of base 10 of 10. I think we should know what that is from using power law, but we can prove it by evaluating it. So what we need to do is do log of base 10 of 10 equals x. Then we need to raise, right? We need to raise, and the answer will be equal to that. So we're going to get 10 to the power of x. So that's raise, and the answer will be equal to that. That will be equals to 10. But this is also what we know as 10 to the power of 1, because 10, anything to the power of 1. So x to the power of 1 equals x, and x to the power of 0 equals 1. In this case, x to the power x is actually x to the power of 1. So now we have 10 to the power of x equals 10 to the power of 1. Because the base is the same, the power will be equal. So therefore, x equals 1. So we just proved that. So now what we now need to do is say log of 10, level 10, equals 1. So that's one of the laws of logarithm. Let's try another one. It's getting exciting now, so let's do another example, which is a bit challenging, so but I'll put it in. So evaluate log 16 to, let's see, evaluate log 16 to level 8. In this case, what we need to do is do log of 16, 8 equals x. We always equate it to x because we don't know what it is. So it doesn't have to be x, it could be any variable in this case. The variable in this case is x. So we can call it t if you want. Therefore, we need to raise and equal to the level. Always equal to the level when you raise it. Doesn't matter what's in the level. It's always equal to the level. So in this case, it will be 16 to the power of x equals to 8. But the clue is not showed there. We cannot see the clue. But I can write 16 equals 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. So that gives me 2 to the power of 4, because that's 1 plus 1 plus 1 plus 1. If the base is the same, when you're multiplying them, the power will be added. So 2 to the power of 4. And I can also write 8 as you can see, 2 times 2 times 2, which is 2 to the power of 3. So what I'm going to do is replace my 16 and 8 with 2 to the power of 4 and 2 to the power of 3. So I'm going to get 2 to the power of 4 of power x equals 2 to the power of 3. So I've just replaced 16 with, so I've replaced 16 with 2 to the power of 4. That's what you see there. And I've replaced 8 with 2 to the power of 3. And therefore, I get 4 times, this is another logarithm we're going to look at. 4 times x will be 2 to 4x equals 2 to the power of 3. And therefore, the base are the same, and there's an equal sign between them. Therefore, their powers will be equal. So 4x equals 3. And therefore, x, we divide both sides by 4, x equals 3 over 4. So now I can rewrite this expression for my logarithm, which is log of 16 level 8 equals 3 over 4. Okay, those are slightly challenging, but you'll come to understand it as we go through the laws of logarithm.